Question is, T-type master-slave JK flip-flop is shown in figure along with the clock and the input waveform. The QN output of the flip-flop was 0 initially. Identify the correct waveform for the output. See, here the flip-flops we used here, they change its next state. The means its response is going to change to the positive transition of the clock. So the input waveform is given in this way and the clock is given is like this. So we have to draw the waveforms for Q0 and Q1. Q1 is the final output of the JK flip-flop which is shown in the figure. So for the Q0, if we draw the waveform is going to be like this, because if input is 0, the output remains as it is. If input is 1, the output is going to toggle, means complement of the previous state. Here similarly for Q1, it depends upon the Q0. So the final output waveform is Q1, this one. In the circuit shown below, the value of voltage at point P is 12 volts. This is a voltage at point P is 12 ohms. The voltage between gate and source is minus 2 ohms, the value of for n kilo ohms. See, this is the N type of MOSFET. Means we know that when we are looking from the gate, the input impedance of the MOSFET is infinite. So Ig equals to 0. Now here we know Ig equals to 2 milliamps from the given data. That is 16 minus 12 by 2K. We got Ig equals to 2 milliamps. Now Vg equals to Vgs plus IDRs. Now Vgs is equals to minus 2 volts which is given in the data. So Id equals to 2 milliamps, Rs equals to 4. So this is Vg equals to 6 volts. Now 6 volts 16 into 42 divided by 42 plus R. So 42 plus R equals to 112. So R equals to 112 minus 42. So it is equals to 70 kilo ohms. Hence option D is correct.
Two magnetic materials placed side by side, identify the leakage flux lines. Okay, now what is leakage flux? Leakage flux means the winding flux which links only itself. Okay, if you see here, there are three flux lines, 1, 2 and 3. Okay, which is numbered as 1, 2, 3. Okay, now if you see 1 and 3 here, this is linked with coil 2. Let us take this as coil 2 and this one as coil 1. Okay, these 1 and 3 flux lines will link to coil 2. So this is called as mutual flux. Mutual flux is responsible for work done in magnetic circuits. If you see here, flux 2, okay, which is numbered as 2, it links the winding with itself. Okay, that is coil 1 itself. So this is called a leakage flux. So option is 2 only, that is option C. In this question he has given a transformer which is rated on primary side. Okay, let us take it as high voltage side, that is 2200 volts. On secondary side it is rated at 200 volts. Okay, it is having magnetizing reactance, that is Xm is equal to 4.4 kilovolts and fictitious resistance R0 is equal to 5.5 kilo ohms. Okay, it is measured when HV side is energized with rated voltage. Now when you recall this equivalent circuit here, okay, now this is the equivalent circuit for the transformer. This is R0 and fictitious resistance and this is magnetizing reactance Xm. Now this is negligible. This is rated voltage 2200 volts on primary. Okay, now what is R0 there? R0 is 2200 by 5.5, which is equal to 0.4 amperes. Okay, this is current through R naught. It generally referred as core component of current IW, which is equal to 0.4 amperes. Okay, current flowing through R naught is IW and current flowing through XM is I mu. Total current is I naught. Okay, now similarly, what is I mu here? I mu is equal to 2200 by, okay, what is this? Magnetizing reactance measured. Magnetizing reactance measured as 4.4 kilo ohms. Okay, now what is this one? 4.4 kilo ohms, which is equal to 0.5 amperes. Now we have to calculate exciting current on HV side, that is I naught. Okay, I naught is equal to IW square plus IM square. So this is equal to square root of 0.4 square plus 0.5 square, which is equal to 0.64 amperes. So option D is correct. A NPN and PNP transistor are connected back to back in such a way that they form three junctions. Okay, he has given a thyristor. NPN transistor and PNP, they are connected in back to back. They will form a thyristor. Thyristor has 4 layers and it is having 3 terminal device: anode, cathode and gate. And back to back thyristors will form this one, PNPN layers. There are 3 junctions, J1, J2 and J3. Okay, when anode to cathode voltage is positive, J1 will act as forward bias, J3 will act as forward bias and J2 will act as reverse bias. Okay, now if this is acting as reverse bias, this does not allow current flow through the thyristor. Okay, this does not allow current flow through the thyristor. This is just like an insulating material. It is acting like a capacitance in forward bias. Okay, J2 is acting like a capacitance in forward bias. Now what is I? I is equal to dq by dt, which is equal to junction capacitance, that is Cj times of d by dt times of Cj into anode voltage Va. Okay, what can I write this one? This one as Va into d times of Cj by dt plus Cj into dVa by dt. Okay, now the charging current to turn on thyristor, he has given as charging current IC is equal to 15 milliamperes, and we have to find critical dV by dt. Okay, that is dV by dt is equal to how much? If you see here, the change in junction capacitance with respect to time is almost 0. We will take it as 0. Now charging current IC is equal to Cj times of dV by dt. Okay, this is nothing but V is equal to anode voltage Va. Okay, now charging current he has given by 50 milli by junction capacitance he has given as 25 picofarad, which is equal to dV by dt. Okay, now this is equal to 600 volts per microseconds. That is option C. Now in this he has given a suspension insulator having 3 units. Okay, if this is a tower, now there are 3 units. Okay, this is unit 1, unit 2 and unit 3. Okay, this is capacitance found between the insulator pin and tower body. Since tower body will act as ground, okay, the capacitance will be found between this insulator pin and tower body. Okay, now what he has given in this question is he has given a self capacitance of C and a group capacitance of 0.C. Now what is K here? K is equal to 0.2. Okay, now we have to find string efficiency. String efficiency is given as voltage across the string, that is V1 plus V2 plus V3 by number of discs. Okay, number of discs are 3 into voltage across nearest to the conductor, that is V3 into 100. Okay, we know that V2 is equal to 1 plus K times of V1 and V3 is equal to 1 plus 3K plus K squared times of V1. Now string efficiency eta S is equal to V1 plus 1 plus K times of V1 plus 1 plus 3k plus 5k square times of v1 by 3 times of 1 plus 3k plus k square times of v1. Okay, if you substitute k is equal to 0.2, okay, we will get string efficiency as 78%. That is option C.